Hello and welcome, guys. So, welcome to another session on number system. We have already covered three topics on number system, and this is going to be a fourth session. Like we are doing, we are covering the nuggets of concepts that are critical to number system. It's a little, it's an area in itself. You see uh, at least 2 to 3 questions coming in can from only number system. So that's why we said, and there are a lot of concepts that needs to be learned. So that's why we are going it small chunks of concepts, and possibly by sixth or seventh video we'll be able to wrap all the concepts. Then we'll do a typically 3 sessions of problem solving on number system once you have the grasp of all the key concepts on number system. So today we are going to talk about an important concept that is on successive division. So what is successive division? That we will understand. We will see if there is any particular formula for it, and what are the most common type of problem you can expect in successive division. We will not solve too many problems right now. We will solve few examples so that your understanding gets cemented, and from there we will wrap today's session and come up with the next topic in the next session. So that's what's the agenda for today. And so successive division, if I see, if I have, let's say, a number, let's say the number is 120. So, and then you divide the number, divide by, let's say there are three numbers. One is, let's say, 11, 5, and 3. Okay. So you divide 11, 5, and 3, but successively, not you are dividing 120 by 11, 120 by 5, and 120 by 3. So it's successively. So first, so as we know, in any division, you have a divisor. You have a divisor. Then you have a quotient. And then you have a remainder. Okay. So 120 first. So 120 will first get divided by 11. So let's say then the 11 is the divisor. What will you get? What will be the quotient? 11 by 120. If I do here 11 by 120, I will get let's say 10. So 110. Sorry, 11 nines are 99, 11 tens are 110. Okay, and I get 10 as a remainder. So my quotient will be 10 and my remainder will be 10, right? Now my this quotient will become my dividend in the next stage. So my dividend here, so this is my dividend for the number. My dividend here is 10. So let's say instead of 5, I have 6. Instead of 5, I have 6. So my divisor will be 6. My quotient will be 1. So if I divide 6 by 10, I'll have 1 and I have 4 as remainder. So 4 will be my remainder. Then again, my quotient become my dividend and my divisor is 3. My quotient will be 0 and my remainder will be 3. So if you divide 3 by 1, you will get 0 here and you will get 3 as a remainder. Yeah. So 3 will not completely divide by 1. So everything will become your remainder. So that's how we do it. So basically your quotient on the first stage becomes the dividend in the second stage. Quotient on the second stage becomes your dividend in the third stage. So that is basically called as successive division. Once you basically, if you have three numbers dividing a number successively, when you divide the first number or the given number with the first divisor, you get a quotient. That quotient becomes your dividend in the next stage. That quotient becomes a remainder. So basically, that's how we do it. So that's how you do successive division. So first quotient becomes the dividend in the second stage. Second quotient becomes the dividend in third stage. And if you have more numbers, that is the normal practice that we follow. So let's take with a generic example. Okay. Let's take a generic example. Okay. before generic example, let's say there is a number when divided by 6, 4, and 2 successively gives remainder of 4, 2, 1. Find the number or the minimum number. There may be more than one number which will satisfy this criteria. Let's see, we have to find out the minimum number. So let's say the number is n. Okay, the number is n. If you have a divisor, quotient, and remainder, let me try to build this. So you have number. Okay, the number is n. First, you are dividing with 6. Okay, your quotient, let's say, is q1, and you get a remainder of 4. Right? This is your first stage. So can I say my n is 6q1 plus 4? Okay. Now in the second stage, your dividend becomes q1, and then you are dividing with 4. Let's say your quotient will be a different q2, and you get a remainder of 2. So can I say my q1 is 4q2 plus 2? Okay, my is 4q2 plus 2. Then in the third stage, your q2 becomes your dividend. You divide by 2. Q3, let's say, your quotient, and you have a remainder of 1. So then I can say my q2 is 2q3 plus 1. Okay. So this is what we got from the motion. Now, idea is to find out what is the minimum value of n. So let's say, so you understood this part. So let's say if I write it, I'm rewriting the equations in the next step. So I got n equal to 6q1 plus 4, q1 equal to 4q2 plus 2, q1 equal to 4q2 plus 2, and then I got q2 equal to 2q3 plus 1. Right? So here, if I just replace q2, I will get q1 4 into 2q3 plus 1, or we can say 8q3 plus 4. So I now got q1 in terms of q3. 4. Oh, there was a plus 2 also. Plus 2. So 8q3 plus 6. So now I got q1 in terms of q3. Now let's replace q1 here. So from here I get n equal to 6 into 8q3 plus 6 plus 4. So you get 48q3 plus 36 plus 4, or we get 48q3 plus 40. So this is n, which satisfy by taking into consideration what should be the q2, what should be the q3, taking all the consideration. Okay. So we got 48q3 plus 40 then as the value of n. Now the minimum value of q3, which is a quotient, can be equal to 0. Quotient minimum value will be 0. And then minimum value of n will be 48 into 0 plus 40 or 40. The next value of n will be 48 into 1 plus 40, which is 88, right? And how we can establish that? Let's say you first divide, minimum value is 40. If you divide by 6, you will get 6, 36, 4 as a remainder. Now 4, now this 6 becomes here. So if you divide 4 ones are 4, you get 2 as a remainder. Now this 1, when you divide, this 1 will become here 1, 0, and you have 1 as a remainder. Okay. So now you got what we are trying to do. Now to have a general information, a generic equation of a number, or like the previous problem, what is the generic equation? Let's say you have to find the minimum number or n minimum, or you can say the generic value of n. N is equal to d1 into d2 into d3 into k, plus I will tell you what is d1, d2, d3 to k, to d1 into d2 r3 plus r2 plus r1, right? So here your d1, d2, d3 are your divisors, successive divisors. R1, R2, R3 are your remainders. So in the previous example, my D1, D2, D3 are 6, 4, and 2. 6 into 4 into 2, that is 48k, plus you got here 6 into your D2 is 4. What was your D1, D2, D3? 6, 4, 2. R1, R2, R3 was 4, 2, 1. So 4 into R3 is 1, plus R2 is 2, plus R1 is 2, right? So if you do this, 4 to the 6, 36, and R1 is 4, sorry, R1 is 4. So 36 plus 4, 40. So you get here, from here, it's a 48k, plus you get from here, you get 40. This was the value we got. So this is the most generic form of equation you can remember. If there are three numbers successively dividing one number, how will you get the number? If you don't want, if you can remember this formula, it's good, but this is not a must remember formula. This is a good formula if you remember on top of your mind. You can actually apply it, but be sure where you are multiplying with R3, where you are adding R2, where you are doing that. So if you can remember the formula as a whole, it's very good. If you can't remember the formula as a whole, that's why I did the first approach, where we kind of form the equations and then replace the values and then get a equation for n and get the minimum value of a quotient. The last quotient, what will be the minimum value? And from there, we kind of got the value, minimum value of the number, and then the subsequent numbers. So that you can do if you don't remember this formula. But if you were remembering this formula as a whole, perfect, go ahead and you can apply, replace these values and get the answer. Okay, now moving to the next time, what are the prominent type of problem that can come here? So it may ask, if you see a lot of problem in hand comes, how many 2's are in 10 factorial for a number? How many 2's are there in 10 factorial? Now we know what is 10 factorial. 10 into 9, 8, 7 into 6 into 5 into 4 into 3 into 2 into 1. So 10 factorial is a multiplication of all this. Now if I break it into small chunks, 2 into 5, then you have typically 9. 9 does not have any 2. I'm just focusing where there are 2's. Then 2 into 2 into 2 for 8. 7 does not have any 2. For 6, we have 2 into 3. Then we have 5. Then we have 2 into 2 for 4. Then 3. Then we have 2. Then we have 1. So how many 2's we have? So we have 1 here, 2, 3, 4, 5, 6, 7, 8. So when I say 2 to the power 8, and then the rest of the numbers. So then when I say there are 8 2's in 10 factorial. So obviously, if someone asks you 100 factorial, you cannot do it in this way. So this is basically nothing but a application of successive division, not the way exactly someone asking you to find the number. It's basically asking you how many of a power of a prime factor is there. So let's say the better way to do it is, first if it is a 10 factorial, okay, then first you do find out, if your question is find out how many 2's, then your first approach should be 10 by 2 is a box. And what the box will give, I will come. Then the next will be 10 by 2 square. Then it will be 10 by 2 cube. Then it will give you 10 by 2 to the power 4 and so on. Why I will say you can stop at 2 to the power 4, I'll come. Okay. So the box of X means least or we can say the largest integer greater than X. A very, very important understanding. A box of X means largest integer, largest integer not greater than, lesser than X. Largest integer lesser than X. So for example, if I write 3.2, box of 3.2, that means it is 3. If I write box of 4.9, that means it is 4. If I write box of 2.7, that means it is 2. So it's always the largest integer which is lesser than the value in the box. Okay. So from here, 10 by 2, I will get 5 in the box. 10 by 2 square, I will get what? 2.25 in the box. 2 square is 4. So that means you will get 2.5, not 2.25, 2.5 in the box. 10 by 2 cube, you will get 1 point something in the box. 10 by 8. 10 by 2 to the power 4 is basically 0. 10 by 16. 10 by 16 is 0 point something. And if you do 10 by 2 to the power 5, it will again be 0 point something. So basically, since the moment your numerator is less than your denominator, you should stop this calculation. So box of 5, the largest integer lesser than 5 is 5. Largest integer lesser than 2.5 is 2. Largest integer lesser than 1.xx is x. And then here it is 0 and continuous it will be 0. So your answer will be 8. So this is one way of calculating, find out how many of a particular prime number is there in a particular number. So similarly, if I say 100 factorials, can you tell me how many 3's, right? So again, the same approach, 100 by 3, obviously box, 100 by 3 square. The moment power of 3 goes above 100, we will stop. 100 by 3 cube, 100 by 3, 4 to the power 4. 3 to the power 5 is 243. It doesn't make sense to add it. So we can stop here. So this will become 33.86. 100 by 9, 3 square is 9. 100 by 9 is 11.86. Plus 100 by 27 is basically 3.86. 100 by 3 to the power 4 is 1.86. 3 to the power 4 is 81. 100 by 81 is 1 point something. So this is 33. This is 11. This is 3. This is 1. So 44, 47, 48. 48 is the number. Now you're getting it. So basically, how you can find out how many 3's are there in 100 factorial? This is the way to calculate. The other way, another thing you need to remember, if the same problem I said 100 factorial, how many 6's are there? So now I know previously we did 2 and 3. 2 and 3 are prime numbers. For 6, 6 is not a prime number. So you can't do the previous box approach with 6. So you have to break 6 into prime numbers. So 6 is nothing but 2 into 3. Okay. Now you have to check how many 2's are there and how many 3's are there. So first let's see how many 2's are there, because I need 1, 2 and 1, 3 to make a 6. So let's see how many 2's are there first. So 100 by 2, 100 by 2 square, 100 by 2 cube, 100 by 2, 4 by 2, 5, 100 by 2, 6. 2, 7 is 128. So we will stop, will not go there. This is a box. So this is 50. 4 by 100 is 25. 8 by 100, it will be 12.xx in the box. As this is 16, so 6.xx. 32, so that means 3.xx. And 64 will be 1.xx. Right? So this is equal to 50 plus 25 plus 12 plus 6 plus 3 plus 1. So 50, 75, 87. 87 is a 93, 96, 97. So there are 97 twos. But we saw in 100 factorial in the previous problem, there are 48 threes. So even if there are 97 twos and 48 threes, and I need for a 6, I need 1, 2, and 1, 3. So that means at max, I can create 48 sixes because 48 twos into 48 threes will give me 48 sixes. Now, obviously, for the rest of the 49 twos, I have 97 twos. The rest of the 49 twos, I don't have any more 3. So if I don't have any more 3, how will I make it a 6? 2 alone cannot make it a 6. So that's where you need to figure out how to find out of a prime, not a prime number or a composite number, how many of the composite number in a particular factorial. That is the way you need to break the composite number into its prime factors and see how many of that you can get to get to make the composite number. Whichever is the lesser number of prime numbers you have, which is a mandatory one in that composite number, that's the number of composite number you can get. So you have 48 threes, you have 97 twos, but you can get 48 threes for 48 twos and make 48 sixes. But for the rest 49 twos, you don't have any more 3 to make it a 6. So you cannot generate any more 6 apart from out of those beyond those 48s. So that is where you need to understand this. Also, then there may be certain problems you see. They say there are 25 threes in n factorial. Find minimum of n. Okay, 25 threes in n factorial, right? So you will have options. So the best way to go ahead with options and see which options possibly suit. But if you don't have options, you can take any random number. Let's say 50. Okay. Say 50, 50 by 3, 50 by 3 square, 50 by 3 cube. 3 to the power 4 is more than 50, so not needed to go there. You do a box, you will get from the first one, you will get 16. You will get 5 from here and 27, so you will get 1 from here. So there are 22 threes in 50 factorial. Okay, 22 threes in 50 factorial, right? Now you can try it with 60. 60 will also have 22 threes, right? 60 will, okay, let's see for 60 what we'll get. 60 by 3, 60 by 3 square, 60 by 3 cube. 3 to the power 4 is again more than 60, we will not go there. This is 20. 60 divided by 9 is a 6.xx. And 60 divided by 27 is 2.xx. So we'll see 26 plus 2, 28. 28 threes in 60 factorial. So your answer should be somewhere between 50 and 60. So 28 threes in 60 factorial. So your answer, somewhere between 50 and 60. Now, you can just take an example. Let's say, so I can see there are 28 and then there are 22. So I need to see how many of them are in 55. So that way you can keep narrowing down and get the number. So for 55, if I do 55 by 3, 55 by 3 square, 55 by 3 cube, if I keep taking the box values, so that is 18, 9, that is 6, and then this is 27, so this is 2. So here I can see I can get 26 threes. So between 50 to 55, you have to see. So between 55 has 26 threes. Now 55 in itself is not a multiple of 3. 54 will be a multiple of 3. So 54 possibly contributing that one extra 3, right? So can I see at 53? So can I see at 53? 53 is 3 by 3. If I do 53 by 3 square, 53 by 3 cube, and stop it. So that means I get 53, that is 18.xx. First one is 5.xx. Okay. And then 53 by 3 cube is 27, so 1.xx. So here I get 24 threes in 53 factorial. We got 26 threes in 55 factorial. So your answer should be 54 factorial is the answer. Okay. So that's how you can narrow down and try solving this problem. With the options, it's far more easier. You can narrow down the options and try to check it. So this is how we can solve some of the successive division problem and the number of a particular prime number or a composite number in a factorial. So these are the prime two concepts that we want to cover today. I hope you understood this. Please feel free to drop a note if you have any doubt. There is a mail ID given in the description box. You can drop a mail to me and I'll respond, or you can drop a comment, I'll respond. But please go through the previous videos, first 3 videos of number system. This is the 4th session. We'll have possibly 2 or 3 more sessions on number system before we completely wrap all the concepts, and then we'll jump into the problems. But yeah, it will be very much required if you can keep yourself completely updated with the latest topics that we covered in number system, and solve few problems. The type of problems that I have solve same type of problem. And then once we start a deep diving into problem solving, we'll solve each of these problem again, so that around 9 to 10 sessions of number system, end of that you will be completely ready with number system. Okay, so see you next time. Thank you. Have a good day. Bye.